Hi, my name is Aviah Stillman.
And I'm Stephanie Gegenheimer, and today we're going to find the force that it takes to push in a button on a water gun carnival game. Unfortunately, we do not have a carnival game itself to solve for the exact force, so we'll be estimating using a hose.
So here's our hose, and so we're going to use this in order to approximate the flow rate of the jet from the carnival game. And so as you can see, I have this hose on jet setting. So it's pretty close to what you'd see at the carnival game. And so I have this measuring cup, and it goes to 500 milliliters. And so in order to approximate the flow rate, we're going to time it to see how long the jet will take to fill this to 500 milliliters. Okay, ready, set, go. Stop. And so now we see that we have our measuring cup filled with 500 milliliters. No, that's like 400.
Okay, so this is our diagram, and we're going to be solving for the anchoring force. And we decided to remove the water coming out of the sides because it's so small we can neglect it. So we filled up our measuring cup to 400 milliliters, and we timed it and got a time of 4.46 seconds. And in order to solve for this force, we use this formula. And we decide to keep m dot as negative because the water is going into our system. But we need to solve for our velocity and our area. And the area is defined from the diameter of the water coming out of the hose.
So we measured the diameter of the hose, and the diameter of the jet was about 1/8 of an inch, but we need to convert this to metric, and so we did that right here. So the radius is equal to 1/8 of an inch divided by 2 because this is the diameter, and then used the conversion and then got this 0.001587 meters. Okay, so then we also need the area in order to eventually compute the velocity. And so our area formula, pi r squared, plug everything in, you get 7.793 times 10 to the negative 6 meters squared. And so then we wanted to know what the flow rate was. But first we needed to convert our volume from 400 milliliters to meters cubed. And so over here, that's what we did. So 400 milliliters, that's equal to 0.4 liters. And then we used the conversion 1,000 liters to 1 meter cubed. And then we got 4 times 10 to the negative 4 meters cubed for our volume. And so the flow rate we said was equal to the volume divided by our time that it took to fill the cup to that volume. And so we got 8.97 times 10 to the negative 5 meters cubed per second. And so now we can finally solve for our velocity because that's just the flow rate over the area. And so 8.97 times 10 to the negative 5 divided by 7.793 times 10 to the negative 6 is equal to 11.51 meters per second. So now that we know our velocity, we can plug in all of our numbers back into our formula, and then we can solve for the force, which is 1.03 newtons.